Welcome back to another episode of Innovate Now, the pulse of future technologies. I'm your host, Josh, and today we're delving into a topic that's as intriguing as it is ominous: biosecurity. In its simplest terms, biosecurity refers to the procedures and measures taken to protect against the malicious use of biological agents. These agents could be viruses, bacteria, toxins, or other harmful biological substances. Now, while the term might be somewhat new to many, the concept itself has been around for centuries. Essentially, it's about safeguarding life, our lives, the lives of animals, and even our environment, from threats that can't always be seen by the naked eye. Biological warfare, or the use of pathogens and toxins as weapons, is unfortunately not a new concept. From ancient civilizations that poisoned enemy water supplies, to the more recent world wars where nations researched and developed bioweapons, this form of warfare has always been a dark chapter in military history. It thrives on invisibility, making it one of the most insidious and feared weapons in any arsenal. Many of us still recall the anthrax attacks in the US shortly after 9/11. Envelopes containing anthrax spores were mailed to media outlets and senators, leading to 5 deaths and many more infections. And then there's the concern about naturally emerging diseases, like the Spanish flu of 1918 or more recent outbreaks like Ebola and COVID-19. While these weren't acts of warfare, they showcase the sheer power and spreadability of biological agents, underscoring the necessity of strong biosecurity measures. In today's episode, we'll be dissecting the realm of biosecurity from multiple angles. From the technology employed to ensure our safety, to the ethical debates surrounding biowarfare, and even the international collaborations in place to counteract these threats. Our aim? To provide a holistic, well-informed view on why biosecurity is not just a military concern, but a global one that intertwines with our daily lives. As we venture into the realm of biosecurity, it's paramount to start with the very foundation of the subject: biological warfare. The idea of using living organisms or the toxins they produce as weapons of war might seem like something straight out of a science fiction novel, but the harsh reality is that it has deep historical roots, and its potential remains unsettlingly viable today. Biological warfare isn't just about harnessing a disease and using it as a weapon. It's a psychological tool. The invisibility and unpredictability of a biological attack can induce widespread panic, disrupting societies and economies even before the first symptoms appear in the affected population. In essence, it's a tool of both physical and psychological warfare, a two-pronged approach that can cripple nations. Going back in history, there are traces of biological warfare being utilized. For instance, back in the Middle Ages, besieging armies would catapult plague-infested corpses over city walls, turning disease into an ally. Fast forward to World War I, and there were genuine fears and accusations from both sides about the potential use of biological agents, though large-scale deployment was never officially documented. In the modern era, the line between researching diseases for defensive purposes, to develop vaccines or treatments, and for offensive purposes, weaponization can be incredibly thin. The Biological Weapons Convention, BWC, of 1972 was a significant milestone in global efforts to ban the production and possession of biological weapons. However, verification remains a challenge, and clandestine programs can be hard to detect. The technological advancements of the 21st century have brought with them new challenges and concerns. With the advent of genetic engineering, CRISPR technology, and other biotechnological tools, the potential for creating more potent and targeted biological weapons has grown. The dual-use nature of these technologies, they can be used for both beneficial and harmful purposes, makes them particularly difficult to regulate. But it's not all gloomy. On the brighter side, the same advancements that could be used to weaponize pathogens can also be employed to better detect, treat, and prevent diseases. Global collaboration, transparency, and strict adherence to international norms and treaties are the shields against the misuse of biology. Yet, as history has repeatedly shown us, with every new frontier of warfare, there arises an ethical conundrum. How do we balance the pursuit of knowledge with the potential for destruction? How can we ensure that the study of pathogens for legitimate scientific and medical purposes does not inadvertently or intentionally lead to a new arms race? In the rapidly evolving realm of biotechnology, where scientists can edit genes with precision and harness the mechanics of life itself, there lies a profound dilemma, a dual-use dilemma. This term, Dual use refers to technologies and research that have both beneficial applications and potentially harmful ones. When we examine biotechnology through the lens of biosecurity, this duality becomes not only a scientific challenge, but also a moral, political, and strategic quandary. At the heart of modern biotechnology is the promise of revolutionary breakthroughs. Think about personalized medicine, where treatments are tailored to an individual's genetic makeup, or the potential eradication of hereditary diseases through gene editing tools like CRISPR-Cas9. We've seen the advent of synthetic biology, where organisms can be designed to produce biofuels, clean up pollutants, or manufacture drugs. These advancements herald a future where the lines between biology and technology blur, promising a brighter, healthier, and more sustainable future. However, the same tools that can edit out a genetic disease or create biofuels can also be repurposed for nefarious intentions. For instance, a pathogen could be genetically modified to be more virulent, resistant to current medicines, or even tailored to target specific populations based on genetic markers. What's more, with the democratization of biotechnology tools and knowledge, these capabilities are no longer confined to state-run labs. They could potentially be accessed and misused by non-state actors, including terrorists or rogue entities. The recent advancements in synthetic biology further exacerbate this dual-use dilemma. It's now possible to synthesize deadly viruses from scratch using publicly available genetic sequences. In 2017, a team of Canadian researchers managed to recreate the horsepox virus, a relative of the deadly smallpox virus, using mail-order DNA. While their intentions were purely academic, the feat highlighted a critical biosecurity concern. In the wrong hands, such capabilities could resurrect eradicated diseases or create novel bioweapons. This brings us to the critical challenge of governance. How do we regulate and oversee a field that is both global and rapidly evolving? Traditional mechanisms of arms control, designed for nuclear and chemical weapons, may not be apt for the fluid nature of biotechnologies. Efforts to control the dissemination of knowledge, like censoring scientific publications, could hamper legitimate research and international collaboration. Furthermore, the line between defensive and offensive biological research is often blurry. A lab working on a vaccine for a deadly disease might be indistinguishable from one trying to weaponize the same pathogen. The Biological Weapons Convention, BWC, which bans the production and possession of biological weapons, lacks a robust verification mechanism, making compliance checks challenging. In navigating this dual-use dilemma, a multi-pronged approach is essential, enhancing international cooperation and trust, fostering a culture of responsibility among scientists, and establishing robust oversight mechanisms are paramount. Transparency, both in intentions and actions, will be vital. Additionally, investing in rapid response and mitigation capabilities can act as a deterrent against the misuse of biotechnologies. As we delve into the world of biosecurity, it's evident that the stakes are high. The dual-use nature of biotechnologies, as we've discussed, presents a unique challenge. But if history has taught us anything, it's that with every threat comes the pursuit of defense, and biosecurity is no different. Now we'll explore the multifaceted strategies in place to defend against biological threats, ensuring the safety of nations and individuals alike. The very nature of biological agents, stealthy, mutable, and at times undetectable, demands innovative solutions. So, where do we start? One of the foundational pillars of biosecurity is continuous surveillance. This involves real-time monitoring of potential outbreaks, unusual patterns of diseases, and timely reporting. The World Health Organization's Global Outbreak Alert and Response Network is a prime example, working to detect, verify, and counteract disease outbreaks. Modern technology also plays a pivotal role, with AI-driven algorithms now scouring vast data sets to identify potential threats, even before they become apparent to humans. Early detection is only half the battle. The ability to respond swiftly and effectively can be the difference between containment and catastrophe. This encompasses not only medical responses like vaccinations and treatments, but also logistical and communication strategies to quarantine affected regions, ensure the public is well informed, and prevent widespread panic. In the event of an outbreak, having a stockpile of essential resources, including vaccines, antibiotics, and antivirals, can save countless lives. These stockpiles must be continuously updated to ensure efficacy, and account for evolving biological threats. Biological threats recognize no borders. Thus, international collaboration is not only beneficial but essential. Joint research ventures, shared intelligence, and coordinated response plans ensure a unified front against potential threats. Building a robust defense against biological threats isn't just about technology and resources, it's about people. Training healthcare professionals, first responders, and even the general public about potential threats and appropriate responses is a crucial aspect of biosecurity. Promoting a culture of safety and responsibility within the scientific community ensures that research advancements don't unintentionally become threats. Regular audits, stringent lab safety standards, and oversight mechanisms can prevent accidental releases or misuse of biological agents. The Biological Weapons Convention, BWC, serves as a testament to global efforts against the weaponization of biology. Diplomatic efforts to promote its objectives, ensure compliance, and expand its scope are essential facets of global biosecurity. Singapore, a small city-state with a high population density, recognizes the profound threats posed by infectious diseases. Over the years, it has meticulously developed robust biosecurity measures. Singapore was hit hard by the SARS outbreak in 2003. Post-SARS, the country made a commitment to bolster its defenses against infectious diseases. Singapore developed the Biosurveillance System for early epidemic detection, a real-time monitoring system that collates data from multiple sources like clinics, hospitals, and laboratories. The system's primary objective is to detect and respond to infectious disease outbreaks early. Further, the nation's National Center for Infectious Diseases acts as the frontline facility for disease outbreaks. This state-of-the-art facility can house over 300 patients in isolation rooms, ensuring that contagious diseases don't spread within the community. The nation also places a strong emphasis on research. The Singapore Infectious Diseases Initiative, for instance, funds research projects that aim to expand knowledge on infectious diseases and develop new treatment modalities. Public education is another cornerstone of Singapore's strategy. Regular campaigns inform citizens about the importance of hygiene, vaccination, and other preventive measures. Additionally, the government collaborates with private tech firms to develop mobile applications that track and trace potential disease exposures, ensuring that outbreaks are contained swiftly. Singapore's multi-pronged approach to biosecurity, involving technology, research, public education, and international collaboration, showcases how countries can effectively shield their populations from the threats of infectious diseases. While biological threats loom large, the structures to combat them, provided they function optimally and collaboratively, offer hope. The nexus of technology, international collaboration, and vigilant organizations can pave the way to a more secure biofuture. Biosecurity, as we've traversed today, is not a standalone issue, but one woven deeply into the fabric of global geopolitics, scientific advancements, and shared human vulnerabilities. From historical instances of biological warfare to the cutting-edge technologies aimed at prevention and mitigation, it's evident that our world, though vast, is interconnected in ways that make collaboration not just ideal but essential. The invisible threats posed by biological agents, both naturally occurring and those that could be weaponized, underscore the importance of being prepared, vigilant, and most importantly, united in our global defense. Yet, as we delve deeper into the technological and strategic realms of biosecurity, it's paramount that we remain anchored in ethical considerations and a shared commitment to the betterment of humanity. After all, the tools, alliances, and strategies we've discussed today are, at their core, about safeguarding our shared human family. Thank you for joining this exploration on Innovate Now. I'm Josh, and as always, it's been a privilege to dive into these pressing topics with you. Remember, as we navigate the future, knowledge is our compass. Until next time, stay curious, stay informed, and always look beyond the horizon.